In this ISSCC paper and demonstration, we present IDS WiMAX baseband SoC and show an average 1 megabits per second wireless connection at 300 km per hour. Emulation system show that IDS WiMAX chip is capable of delivering data rate of 3 to 6 megabits per second with Qualcomm 16 at 3 km per hour. And measurement is consistent with the real high-speed rail field testing.
So here you're seeing a demonstration of the ISSCC paper 7.7, which presents you very low power 65 millimeter 4G WiMAX chipsets. There are four things that are really critical for the WiMAX technology and WiMAX chipset. The first thing is the throughput. You're seeing here we're demonstrating a 7 megabit per second, very high throughput PHY design. The second thing is the power consumption. You see this is a very low power design, not just on the chipset level, but also at the process level. The third thing is the integration of the processor to be able to help produce a very compact and high performance system. The fourth thing is the receive sensitivity. As you can see, that we have the number of throughput here, which is about 10 megabits per second. That is depend on the quality of the HD video we are playing now.
So this demonstration showcases the SiBeam RF transceiver pair in a wireless HD system. Shown here is our simplified transceiver architecture. You see that the two RF chips use the same circuit blocks, but the RF paths are designed to create an asymmetric link capable of 3.8 gigabits per second for full HD video in one direction and 10 megabits per second omnidirectional link for control and coordination in the reverse direction. And right now you can see that the TV and the laptop have a 3 gigabits per second link showing full HD video. And this is acting in an extended display monitor mode. So you can see that we have some video shown here on the laptop screen, and that's also showing up without any lag on the TV itself, and then we have just a trailer looping over on the TV.
This demonstration aims to show that the DA7201 Class D audio amplifier dramatically improves efficiency while maintaining hi-fi audio quality, and is therefore a better choice for reducing end product power consumption. Comparison of the discharge times plainly shows the Class D technology is significantly more efficient, using far less power than Class AB. This power consumption advantage can be shown to be as much as 8 to 1, where the Class D demonstrates 90% efficiency and Class AB considerably less. This drastic reduction in power consumption does not penalize audio quality in the Class D amplifier, and impressive hi-fi parameters can still be achieved.
The emerging ADCs in the market today are really pushing the powers down. If we can't bring the driver power down with it, we've kind of lost the game. Now, one of the problems we're trying to solve here is how to get a single-ended signal, give it a bunch of gain, and get it to the ADC through a low-pass filter where we can control the noise power bandwidth, and do that in a way that doesn't hurt the converter performance. Here we're doing a 10 megahertz input with a 250 megahertz clock, and we can look at the FFTs, and we're seeing that we're getting about an HD2 of 93 and minus 85. That's darn close to the converter itself, but frankly 10 megahertz is really slow for this part. We did take lab data at higher frequencies with sources that are much more difficult to move around. And here we have some tests at 115 megahertz, full scale, two-tone, and right in here we see a couple of tones that are 85 dBc down.
This demonstration shows a communication example between x86 hosts using PCI Express direct link by the communication SoC which we developed. Each chip includes 8 core CPUs and 4 PCI Express ports and several DMA controllers. This is a demo system. 2 desktop PCs are connected via pitch boards and PCI Express external cable. Each PC runs Linux, and each pitch board also runs Linux for M32R with 4-core SMP. In this demonstration, each host PC sends message to remote PC using DMA with 3 pages, that is 12 kilobytes bidirectionally, from left to right and right to left simultaneously. In addition, the number of lanes and lane speed can be switched on the fly. So now this link works at minimum performance, but I can change dynamically to the maximum performance, but communication is not disturbed.